what we're going to do is now go backwards in some sense. Instead of finding zeros from a polynomial, you are going to find a polynomial from the zeros. So pretty much the converse of what we just did minus the graphing. Okay, if we had the graph, we could actually do this pretty well too. So this job here says we are going to write a cubic function in standard form. I forgot an m there, so please update that. And it has the zeros -2, 2, and 3. So I have the answers. I'm looking for the question. And I do want to point out to you, for you English scholars, notice I'm looking for a polynomial. That's an indefinite article. There we go. An indefinite article, which means it's one of many. It's not the polynomial. It's one polynomial that we have choices in. So here's the situation. According to the factor theorem, if we have the expression x minus a, then a is a 0. Conversely, if a is a 0, then x minus a is a factor. So what's the moral of the story? This right here is my 0, which means x minus this number is a factor. What about this one? 2 is a 0. So x minus that 2 is a factor. And notice the last one. 3. Since I have 3 there, x minus 3 is a factor of the polynomial. Since it's a function, I'm going to put y equals. If the instruction said, write a polynomial, you're done. You're done. However, it didn't say stop there. It does say write it in standard form. So I have to get it to cube, to square, and plus some constant, okay? So I need to, in other words, I need to multiply things out. All right, so how do we put this in standard form? In order to put this in standard form, I need to multiply. You have to multiply out. It's going to take us a little bit because we've got a lot of distribution property or distributive property to use. But I do want to point out a few things. Number one, these two are conjugates. These two are conjugates, which means when I multiply those out, it ends up being x squared minus 4. Let me just highlight what I did. These two are conjugates, and they multiply to x squared minus 4. Notice something I haven't included yet, the x minus 3. So I'm going to bring that over and write that in, x minus 3. Now what? What we have to do is double distribution now. Eyes on deck so you can see what's happening here. I need to take the x squared, multiply it there to get x cubed. Then I have to take the x and multiply it to there, the x to get negative 3x squared. Then I have to take the negative 4 and multiply by the x, negative 4x. And lastly, the negative 4 times the positive 3 to get positive 12. Notice it's already in standard form because of the cubic, the quadratic, the linear, and the constant. So here is my answer. And now the next part is asking us to write a quartic polynomial function in standard form with the zeros -2, -2, 2, and 3. Now notice what's going to happen here. I'm going to go ahead and write the function as we did at the very beginning with this up here, where we just use the factors. So we get this, y equals x minus 2, and let me change that to a plus, and then x plus 2 again, then x minus 2, and then x minus 3. Now before we jump into robotic multiplication, try to find some patterns. And notice a pattern here. X plus 2, x minus 2, x minus 3. X plus 2, x minus 2, x minus 3. In other words, this here is the exact same as this here. So since that's the case, whatever I just got from my previous problem, this can be substituted. I've already done a bunch of the multiplication. So what do? I'm going to bring down this right here, x plus 2. And I'm going to substitute this polynomial that I just found. X cubed minus 3x squared minus 4x plus 12. Now we're not done because it does have to be in standard form. So here is a bit of complexity. So we're going to do double distribution. This x is going to distribute to each term there, and the 2 is going to distribute 4 times there. So I'm going to go step by step here and substitute in, or not substitute, distribute out. So y equals x to the 4th minus 3x squared, cubed, minus 4x squared plus 12x. So this x distributed to each term. Now the 2 distributes to each one. So what I'm going to do here is as I distribute, I'm going to write it under the corresponding term. Why? Because I want like terms to line up. So positive 2 times x cubed gives me 2x cubed. So I lined it up with the cubic term. Then I get negative 6x squared, and then negative 8x, and then plus 24. Now we're in a position where I can just combine like terms. It's just like old school adding and subtracting. X to the 4th plus 0 minus 1x cubed minus 10x squared plus 4x plus 24. So this is a polynomial that's quartic that has these zeros there. Again, we're in standard form, 4, 3, 2, 1, and a 0 there. And now what I did was graph both of these using a graphing calculator, and I want to show you some things that are exactly the same. Number 1, 2, and 3 of the roots are the same. Notice what else is the same. They both end going up. What's different? This one starts high, the quartic starts high, and the cubic starts low. So those are some things that are exactly the same. And do notice, though, that the purple one, the purple does not pass through the 2, the negative 2. It bounces off the negative 2, and then passes through here, passes through here. So the green passes through, the purple bounces. But all the other ones pass through here, pass through here, pass up here, pass up here. So we're going to keep that in mind about the bounce right there. All right, so now what we've just finished up is that we have spent some time writing polynomials from its zeros after once we know the zeros, we can plug them in to my factors and expand it out.